All right, welcome back. I hope everything is going well in your world. We are talking about 3.7, some of the homework questions, and I had 2 questions asked for me to do, so we'll take a look at those. We're in 3.7, and we're looking first at number 5. Oh, these ones are a bit long. I may have to erase the board a couple of times, but number 5 has this function. X to the 4th minus x to the 3rd minus 6x squared over x minus 2 squared, and then x squared minus 1. And we're asked to find the vertical asymptotes, horizontal asymptotes, x-intercepts, and y-intercepts. So when I begin with the vertical asymptotes come from the denominator. Right? It's setting the denominator equal to 0, so I have x minus 2 squared times, and this x squared minus 1, it can be factored. I'm just going to rewrite this as x minus 1 and x plus 1. And again, I'm on this very small board, so I may skip a little bit of the work because we've seen this before. When I set this equal to 0, then either x minus 2 is equal to 0, or x minus 1 is equal to 0, or x plus 1 is equal to 0. That gives us our 3 solutions here. X equals 2, or 1, or negative 1. And so when x is 2, x is 1, or x is negative 1, my denominator is 0. That's what gives me a vertical asymptote, is having the denominator 0. So I have those vertical asymptotes. I'll write them perhaps up here on the side. But I have x equals 2. Write them in order. Negative 1, 1, and 2. Right? Hopefully you can see that. Negative 1, 1, and 2. Right? That's our vertical asymptotes. I'm going to erase this, so if you still need to write it down, pause it for a second. Now, the next thing they ask us for are the horizontal asymptote. And the horizontal asymptote comes from 3 different cases. Right? That's in the, I think in George's videos. I'd have to go back and make sure that he talks about it. But it is in the notes under the videos in our section. If you were to expand this, the top is just x to the 4th plus a bunch of stuff, nobody cares, right? After that highest power, it's not particularly important what comes after it. But in the denominator, this x minus 2, if that were to get squared, that would give me an x squared. And then I have another x squared here, which is going to give me an x to the 4th as well in the denominator if I were to expand this whole thing out, expand my denominator. Right? And if I did expand my denominator, the coefficient in front of my x to the 4th is 1. The coefficient in front of the x to the 4th in my numerator is 1. And because these two are the same power, then the horizontal asymptote is y equals, and it's the ratio of the number in front of the highest term of the numerator, which in our case is 1 because it's not written there, divided by the denominator's leading coefficient. So 1 over 1, which is just 1. And so my horizontal asymptote, let me come over here to write it, is y equals 1. All right. So I have those 2 things. I have 3 vertical asymptotes. We're only going to end up with 1 horizontal asymptote because it doesn't make sense to have more than 1. But then they ask us further to find x-intercepts and y-intercepts. So the x-intercepts, if you think about what an x-intercept is, that's when the graph, whatever it's doing, comes down and intercepts that x-axis, right? And that happens when y is 0. So that's how we're going to find these things, is let y, or f of x, equal 0. And so I set the entire function equal to 0. Right? And in order for this fraction, this rational expression to be 0, the only thing I care about is when that numerator is 0. Because if the numerator is 0, the whole thing is 0. This whole denominator doesn't do anything other than cause issues if I happen to have a 0 at my vertical asymptotes. But if I do, I can just eliminate that. And so I really am not interested in the denominator at all for this part of this problem. All I really want to know is when that numerator is equal to 0. And so I'll factor this numerator. This is, there's a greatest common factor of x squared here. So I'll pull out an x squared. That leaves me with x squared minus x minus 6. And then this trinomial can be factored, right? X squared minus x minus 6 can be factored down to x minus 3 and x plus 2, right? And so if I want to solve for when this is 0, again, I'm running out of room on the board. We should see this. We should have been seeing this before, but I get a 0 from the x, right? If all of this is 0, then either x squared is 0, x minus 3 is 0, or x plus 2 is 0. And therefore, I get a 0 from my x, and that's just at 0. My x minus 3 gives me a 0 at positive 3. And then my x plus 2 gives me a 0 at negative 2. And so those are my x-intercepts. So I have negative 2, 0, and 3. Okay. And then we're asked to find our y-intercept. And we'll think about this similarly. I'm going to erase this, so if you need to pause it, go ahead. We similarly look at our y-intercept. The y-intercept is when we cross the y-axis. And no matter what our function is doing, when I cross the y-axis, x is 0, right? And so I can find where my y-intercept is by simply plugging in 0 for my x's and seeing what happens. That is, I'm going to take f of 0 and see what that is. So that's 0 to the 4th, that's still 0. Minus 0 to the 3rd, minus 6 times 0 squared. All over 0 minus 2 squared, but minus 2 squared is positive 4, multiplied by 0 minus 1. So my entire numerator is 0. And so this whole thing is 0. And so my y-intercept is y equals 0. Which makes sense because when x was 0, I had a 0. So it would make sense that my y is 0 when x is 0 as well. And it looks like that's all they asked us for on that problem. So that takes care of everything. I think I've put them in order. I think the problem asks you to put them in order. But these are your solutions for that problem. Yeah, so that's that. The other problem that we had was number 8. People were asking about So number 8 is f of x equals 6x squared plus 1 over 2x squared plus 7x minus 4. And a similar question, I think the biggest difficulty that people had were finding the x-intercepts. So let's go through the whole thing just because it's on the board here. The first thing they ask you to find are those x-intercepts. And again, the x-intercepts happen when the whole function is 0, and the whole function is 0 when the numerator is 0. So that's all I care about, is saying 6x squared plus 1, the numerator, is equal to 0. And I can solve this by subtracting 1. So I have 6x squared is equal to negative 1. Divide the 6, that gives me x squared equals negative 1/6. And you should see here when we have something squared equals a negative, we're probably not going to get a real solution out of this, right? But if I square root this, I can find that I do indeed get the square root of a negative number. That gives me an I, and a plus or minus because it's a square root. But this I, because I square rooted a negative, there are no real zeros. And when we're graphing, we're only interested in the real zeros. And so I'm just going to write that there are no real zeros. Right? For the x-intercept, right? Which is to say, when I'm graphing this thing, I'm never going to cross the x-axis. There's no place on the x line of real numbers that I'm going to cross over. So the next thing they ask us for is the y-intercept. The y-intercept happens when the entire function is 0. So, or sorry, the y-intercept happens when x is 0. So I'm taking f of 0, which is to say 6 times 0 squared plus 1 over 2 times 0 squared plus 7 times 0 minus 4. But you can see all of these zeros. 6 times 0 squared, that's just 0. 2 times 0 is 0. There's a lot of stuff that just disappears. The only thing that's left is this 1, which is positive, and the 4 in the denominator, which is negative. And so this is negative 1/4. So my y-intercept is at y equals negative 1/4. All right, then they ask us for the vertical asymptotes. The vertical asymptotes come from the denominator when the denominator is 0. So this 2x squared plus 7x minus 4 factors down, right? So if you don't know how to do it, right, just take the 2 times negative 4, that gives you negative 8, find the factor pairs. It's the A times C method, right? We've seen that. So I'm going to skip the work here in the name of the space on my board here. But this factors down to 2x minus 1 times x plus 4. And if I set that equal to 0, once again, you should be able to see that the x plus 4 gives me a value of negative 4. And the 2x minus 1 is going to give me a value of positive 1/2. Add the 1 to the other side, divide by 2. And so I have my 2 vertical asymptotes at x equals 1/2 and x equals negative 4. And then, of course, the last thing they ask us for is the horizontal asymptote, which is determined by the leading terms of both the numerator and the denominator. So the leading term of my numerator is 6x squared, and the leading term of my denominator is 2x squared. They're the same power, they're both x squareds, and therefore my horizontal asymptote happens at y equals 6 divided by 2, or 3. And that's everything that they ask us for on that one. No, it's not. They asked one more thing. I lied. The last thing they ask for is, at what point do we cross the horizontal asymptote? Right? You'll never cross a vertical asymptote when you have a function, but it is possible to cross a horizontal asymptote close to 0. Right? It's when you get far out that you start asymptotically going towards that line of y equals 3. But closer to 0, and when we have these zeros of the function, which we don't have here, but close to 0, we can cross over the horizontal asymptote. Once, twice, 3 times maybe, but we can see where that happens because I know that the horizontal asymptote is 3. So the question is, where is my function equal to 3? And so I'm going to take that function, that f of x, this thing, and I'm going to erase a little bit of this. This is the question we're trying to answer. In order to answer it, all I have to do is take that function and set it equal to 3. Because if it is 3, we're crossing the horizontal asymptote. So what I would do then is multiply both sides by this denominator, right? If I multiply the right-hand side by that denominator, it's going to cancel out. If I multiply it on the left-hand side, I'll just distribute the 3 through. And so 3 times 2x squared gives me 6x squared plus 21x minus 12 is equal to, and then I'm just left with the numerator on the right-hand side, 6x squared plus 1. I've got a 6x squared on both sides, so if I subtract 6x squared from both sides, it just cancels out, so that's gone. And I'm left with just a linear equation in x. There's just an x, so I'm going to add 12 to both sides to get my x term alone. That gives me 21x is equal to 13, and if I divide both sides by 21, then I have my answer. X equals 13 over 21. And again, that's where we cross the horizontal asymptote. So that's somewhere between 0 and 1. So between 0 and 1, we actually hit that line, and then we probably do some maneuver and then approach it again. So hopefully that's helpful. Hopefully you can get through this homework. All right, and that'll do it for now, and I will see you guys. I'll post another video. I don't know what today is, whatever day we have class normally. Sorry, I wish I knew what day it was ever. Thanks.